Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's Data Center Knowledge webinar, AI-Ready Data Centers, Uncovering the Essential Infrastructure Upgrades, sponsored by Legrand and broadcast by Informa. I'm Brandon Taylor with Data Center Knowledge, and I'll be your moderator today. We have just a few announcements before we begin. This webinar is designed to be interactive. The dock of widgets at the bottom of your screen will allow you to learn about today's speakers, download resources, share this webinar via social media outlets, and participate in the Q&A session that takes place at the end of our presentation. The slides will advance automatically throughout the event. You may also download a copy of the slides via the resources widget. Toward the end of our webinar, we will ask you all to provide feedback via the survey widget found at the bottom of your screen. Please take a minute to fill this out before leaving us today, as your feedback will provide us with valuable information on how we can improve future events. Lastly, if you are experiencing any technical problems, please click the help widget found at the bottom of your screen or type your issue into the Q&A area, and we will be glad to offer one-on-one assistance. Now on to the presentation. AI-Ready Data Centers, Uncovering the Essential Infrastructure Upgrade. Discussing today's topic is Saman Brookham, Senior Product Manager for Legrand. Again, Saman is the Senior Product Manager under Legrand's Data Center, Power, and Control Division focused on cabinets and containment. He's worked in the cabinet and containment industry for nearly a decade, holding roles in both sales engineering and product management, demonstrating his expertise in both pre- and post-customer support. As product manager, he focuses on developing his portfolio in both categories, which has led to Legrand's leadership position in the space. Saman has received his certified data center design and Six Sigma Green Belt. And just like a data center, Saman believes that the only way forward is through continuous improvement. Joining Saman today is Klaus Daffinger, Cooling Marketing Manager for Legrand. Klaus brings 17 years of expertise in the data center industry with a background in planning, project management, and installations for clients ranging from small businesses to hyperscale operators. Currently, he drives strategic marketing initiatives at Legrand, shaping innovative solutions for the data center market. If you want to ask our speakers any questions today, again, please use the Q&A area that is found on the right side of your screen. Saman, over to you.
Thanks, Brandon. Appreciate it.
You're welcome.
All right. So AI-ready data centers, uncovering the essential infrastructure upgrades. Brandon, if you have any questions from the audience that is pertinent to the slide that we're on before we move on to the next one, feel free to jump in and ask away. Okay, we want to keep this kind of open with the audience.
Definitely.
All right. So let's start at the cabinet level. One of the major trends that we're seeing in today's market is the need for higher static, dynamic, and transportation-ready cabinets. So first, we'll start with the static load. This is a test that almost everyone who deals with data center cabinets is aware of, UL 2416. We have a 5,000-pound weight load capacity as part of our TNT6 platforms. This is a direct result of the increased density of the equipment that's going into the racks, as well as all of the additional PDUs, sensors, cabling, copper, fiber that's going to be loaded within. And we thought it best suit the market today if we increase those weight load capacities accordingly. UL 2416 is a test that basically certifies the structural integrity of the cabinet, ensuring that it's a safe-to-use product within the data center, including when the equipment is loaded. The second testing that we accomplish on our cabinets is a functional or rolling test. This is not an industry standard test like UL 2416. This is a homegrown test that we've developed over many years. And basically the function of this is when the equipment comes off of the pallet, goes into the data center floor, we understand that there could be a significant distance between the dock and the ultimate location of the cabinet. And when this happens, you go over things like ramps, inclines, impacts, some obstacles. Somebody left their badge on the floor and the casters get hung up. And we want to make sure that while the cabinet's being transported within the data center, that it could handle all of these different scenarios while still being a safe to deploy piece of equipment. The last item is the transportation load, and this is something that is fairly common nowadays with AI applications. Is you take your cabinet, you send it to an integrator. The integrator populates the cabinet with their IT equipment, cables it, burns it in if necessary, and then ships it to the end user. That new method of shipping to the integrator and the integrator going to the end customer site has seen a pretty big boom over the last several years. And we've really standardized on the testing protocol that you see above. This does a variety of different, there's a different set of protocols than the other two tests. These will go on shock pallets, be packaged with exterior packaging, typically made out of cardboard. And the sequences are typically rotational drops, a 4-hour vibration test, and a whole host more, ensuring that when the equipment is loaded into the cabinet and ultimately transported via truck or air to the end user, that not only does the cabinet survive, but the equipment also survives. And we've seen a really good result from our testing, making sure that it's very comprehensive, for these types of applications. So all of these tests are basically accomplished on the smallest and the largest sizes within our range. So from our range, we have 600 millimeters and 36 inches deep, all the way through 800 millimeters and 54 inches deep. Every size within that footprint and up to 52 RU is passes all of these tests, and we're really proud of this accomplishment.
And Saman, this is not an uncommon approach to AI deployment. So what is LeGrand doing differently from a packaging standpoint that allows for the customer to do this safely? Is the entire packaging reusable?
Brandon, thanks for that. Yeah, so from the packaging standpoint, what we're seeing is that many of our competitors are using a foam approach to protecting the equipment within. And what this does is it basically puts a lot of pressure on dumping all of that excess material once the packaging is used. So we know that the pallet itself, or where the cabinet sits on, has some sort of foam to protect against the vibration and the damage caused within the trucks, if that is how it's being shipped. But the packaging itself on the outside is really, the functionality is just to hold the cabinet against the truck walls or the method of transportation. So what we've done from an exterior packaging perspective is twofold. The first method is the cardboard method. The cardboard method, instead of the foam internal fill, we've used a cardboard internal fill as well as a metal strap packaging around the exterior. This gives the crush protection that is necessary to protect the equipment within the cabinet, as seen from the test results. And it gives the customer a lot less waste when it gets to the end site. So no bringing of 10,000 dumpsters to take and discard some of this material is really just a knockdown approach that can be recycled even nearby. So the second approach is our crated solution. This is a reusable exterior packaging. So we'd like to see integrators who take the packaging that we provide to them, use it as for the first round, and then have some sort of reflow program where they're bringing the trucks back, or they're taking this exterior packaging and saving it for the next deployment of our cabinets into the data center. That way, we do a little bit more sustainability projects that way, and kind of help all around. The next method that we would like to talk about is the sensors that go within the cabinets. We're seeing a lot of deployments nowadays take into account the ASHRAE standard, which is the American Society of Heating, Refrigeration, and Energy. And we basically see that with the higher load requirements, higher electrical load, a higher heat load within the cabinets, that now sensors are becoming more prevalent because the data analytics behind these deployments is a lot more important. So back in the day when you had 5 to 10 kilowatts per cabinet, it really you really didn't see that much of hotspots or things of that nature. But now with all of the new equipment that's being installed, you're really starting to see some of these concerns within the data center, and people need to understand how to properly accommodate for these new types of environments. So we really recommend having a host of sensors within your aisles. That way you can make decisions about how you deploy your next generation of equipment, or in the future when you're looking to deploy, let's just say, another site, how you would restructure those equipment and IT devices to more evenly distribute all of this load across the environment. So I really like cabinets that have at least temperature and humidity included within these, but our division has a whole host of sensors that could be plugged in directly into the PDUs. And if you export this data into your building control systems, you can definitely take a look at aggregate data across a cabinet, a row, an aisle, etc., and really give yourself a clear understanding of what is happening within each.
I totally agree on what you said, Saman, and I just want to point out the importance of those sensors, because changes and adding equipment in cabinets, that's not new at all. But as you said, so when the load was like 5 to 10 kilowatts per cabinet and you added a server, it was just a slight difference. But with the change in the servers and the energy consumption, the impact on single systems is totally different. So sensors in your systems just to monitor the changes and everything, to have a view on potential hotspots as early as possible is an absolute key. So sensors, very, very crucial.
And so Klaus and Saman, we have a question from the audience. And they're wanting to know, are the sensors standalone, or do they need to be plugged into the PDUs? How do you use the data from these sensors?
Yeah, really good question. So there's two methods that you can go with our sensors. If you buy ServerTech or Raritan PDUs, these sensors are plug and play into those units, and you can daisy chain up to 32 of them off of a single PDU. The other method, if you're not using Raritan or ServerTech, is to buy a sensor module. So we have these standalone units that can be deployed within an entire row and hold up to 200 sensors off that single unit. That way, everything is aggregated into one location, and you have one connection to your building control systems, BMSs, I think, building monitoring systems. And that system would basically allow you to generate graphs and reports and provide warnings when these sensors are above a certain threshold, for example. And that could be all set from the back-end UI of either of those methods. Okay. Lastly, I'll talk about different containment systems. So we have three primary objectives or methods of doing containment within a data center environment. And in general, containment and the segregation of hot air and cold air has been a widely adopted method for current data center deployments. But even more so, this containment is your first step into airflow management within your data center environment. We don't see it as a replacement. We see it as a stepping stone to getting more and more efficient within your data center environment. So in general, you have three methods for containment. You have your ready to install, where the equipment is either known or already laid out within the data center environment. We use either drawings or take measurements on site to determine what the distances are of the row, the height, where you want the containment to land on the tops of the cabinets. And we create prefabricated panels that basically install and hook up to the ceiling, the cabinet, one or both, and have different insert materials depending on the different scenarios within the environment. The second scenario is what I call the DIY method, or the 2x4 and sheetrock method. This is a solution that we've developed where containment applications are not always so clear cut as to what needs to happen or where things need to be located. So we developed a product that has a bunch of standard components, about 10 or 12 of them, that can be used in various combinations to basically design the containment around the existing infrastructure within the data center. And this has really helped in a lot of different situations where construction plans are not always accurate, and the time that it takes to make modifications or to come back to the vendor and ask for new items is not really part of the schedule, I guess I'll call it. And if we are looking to deploy faster and better, we need to have a product that really aligns with that methodology as well. The last solution is what we've seen more and more hyperscale customers do, is what I call a building within a building. This structure is essentially taking all of the requirements that would typically be placed on the building core and shell and putting it down closer to where it belongs at the cabinet and conveyance level. So this structure essentially takes all of the requirements for support for your overhead busway, your copper, your fiber, the docking of your cabinets, and your containment system, and bundles it all into one solution. And then that solution is deployed on concrete, typically, and the core and shell of the building no longer sees those requirements. So this could be really a quick deployment for your building, because you're not putting so much emphasis on what that core and shell can do, but more what the structure that's holding all this equipment can do closer to where it belongs.
Thanks, Saman. And we have a couple of submitted audience questions. And so the first one I'll ask you, what do you see as the most common solution for containment?
Yeah. So I guess I think that question has two different paths that it can take. So hot aisle, definitely more, in the US at least, the hot aisle is definitely more prevalent than the cold aisle systems are. And the second one is, what material choice is the most common within the data center? So on the left image, you'll see a clear polycarbonate insert, and on the middle image, you'll see the twin wall polycarbonate insert. Twin wall is definitely more common, but for applications that where security or visibility is of utmost importance, we see a lot of clients go with the clear polycarbonate insert. So hot aisle, for sure, twin wall, definitely used more often than not. And this clear polycarbonate serves a kind of segment of the market where it's not always clear where the security cameras are in relation to the aisles, and if that security is of concern, that's the method that they would use.
And so, what are some considerations that you've seen customers make to decide between these containment solutions?
Yeah, so from a prefabricated standpoint, those customers are typically very knowledgeable about what's already existing in their space. They have most of their dimensions or can get them, or have a basically faster than normal deployment requirement, and they don't want to take the effort when the material shows up on site to make changes like you would with a DIY method. So that's where we see more of the ready-to-install products going into. On the second, the DIY method, those customers are typically contractors in construction. I've seen new data centers where with unique cooling strategies have to have different methods of containment, and it wasn't always clear where that containment needs to land or if things were to print. So in that image that I'm showing you, this is an actual construction site where the ducts are attached to the wall, and there's a fan that's blowing, that's taking in all of the hot air that's being exhausted by the cabinets, and that was a kind of unique thing that generally a prefabricated installation would not, adhere to. That way, they needed something that they can modify and retrofit on site to kind of accommodate for this unique cooling solution. And on the last one, it's really about speed to deployment. I know a lot of the hyperscale clients are using this type of material. The building core and shell going up very fast, even as fast as 6 months, and basically you have your data center environment at the pod level rather than a whole building kind of surrounding and supporting that. And in general, these solutions are within the up to 15 kilowatt range. For densities higher than 15 kilowatts, there are a lot of cooling solutions that can be deployed. And for that, I'll pass that over to Klaus to speak to.
Absolutely. Perfect. Thanks, Saman. So we talked a lot about sensors and housing and optimization of cooling. But the AI and the HPC, so the trends that we are moving, it accelerated enormously compared to the last year. So meaning the increase and the demand of power and everything in data centers is everything but new. But again, the steps that we are now taking are on a different level. So optimization is absolutely key. The loads and potential loads in the future, in the near future, we're talking about is a total different level than it was in previous years or in the past. So, and this adds a lot of options and complexity when we look at the cooling that you have or potentially available in your data center. So looking from the options that we have, like the crack and in-row cooling, in-row most often used in on-premise, crack very, very popular. The same is for fan walls. We also have rear door heat exchanger as an option, or potentially also immersion cooling. On top of this, on top of the choice that a customer might need to make, we have also a lot of new things that needs to be considered. Like, for example, of course, the increase in power density. So what is it that we're looking for? What is the average load per cabinet look like in the future, in the near future? So we are evolving very, very fast on this one. The same is for the efficiency on which my systems are running on. So a lot of the total energy consumption of the data center is needed for cooling. So this is something that is not only important for your money, meaning the less power you need to cool your systems, the more you can spend on actually powering those systems. And from a colocation point of view, the more energy you have to serve your customers in the end. The next thing is also space and design. So you want to have it on an optimum level and not wasting a lot of space for those new for those HPC and AI applications. Like, for example, an in-row cooling. So you're relatively limited in the space that you can plan, meaning every in-row unit that you need to add adds like 30 centimeters or consumes 30 centimeters of your row. And that's also something that you need to consider. Thermal hotspots and reliability. So we are back at the sensors and the importance of those. So it is most likely not the case for like lethal humans. So there will not be the impact in a data center that from one day to another you will change 100% of your systems and you have like only AI and HPC. So there will be a transition in those. So in your existing data center, you will have new systems that have a higher power demand. So therefore, it is very, very important, and I said this during the sensors, and I will say it again now, so that you monitor your systems, that you monitor your airflow, your temperature, to have the information and that you see potential risk and thermal hotspots within your system, that you can act accordingly, so that you know you might have you might run into trouble there, so you have an idea what to do. And also to know the limitations of your system, of your cooling system. Depending on what technology you're using, you might also be aware of where to place my high power equipment. In-row cooling, for example, you might want to place it next to an in-row cooler, of course, because there is the cold air on the concentrated cold air from the cooler. If we look on a fan wall, then you might want to place the systems, or you have to place the systems that are consumes more power, more cooling power, closer to the fan wall than instead of the furthest point away from the fan wall. It makes just logically sense, but you need to monitor those. The same is if you look at a fan wall, for example, it is also hard to be efficient in cool, specifically HPC racks. Just think about it. If you have a row with 10 cabinets or 20 cabinets, and within the row you have like 2 cabinets that needs 30 or 40 kilowatt of cooling power, or they have a 30 or 40 kilowatt of load, and the other 18 racks, or 8 or whatever it is, they have like the standard equipment with 5, 10 or 12 kilowatts. The fan wall needs to deliver this cooling power to cool the 30 or 40 kilowatts. So we have potentially a total overkill on the other cabinet. So efficiency is also hard to handle with depending on the cooling technology that they're using. Also, a very important one is the regulatory and environmental factors. So a lot of companies, especially big ones, and a lot of governments and everything, they have their own rules and their own set point of the impact on the environment they want to have. So this is also something that is very important. And the cooling of a data center can have a very high impact on this one. So talking about just the PUE, or the energy efficiency, water usage effectiveness, and stuff like this. So very, very important. This is also something that is now way more important than it was like years before. And the last one, and this is where it gets also complicated, or it might be complicated, so is the evolution in cooling technology. So 5 years ago, you had like the crack, the fan wall, the in-row cooling. Some of the big ones had even other cooling solutions already, but the change in the market on all levels is different, so that every customer, if he wants to be ready for whatever is coming in the near future, needs to think of different solutions of cooling. So it might be worth to look at also the rear heat exchanger. It might be immersion cooling, or whatever it is. It is so the complexity is on a total different level. If we look on those, and the points that you have to consider is not only the 5 or 10 kilowatt that you had in the past. It's different now. It's different, and it can be even different from cabinet to cabinet, depending on the architecture and also on the equipment that you're using. So this is a very we see a really huge impact on cooling in the times that we are now in, the change and the movement of the AI and the HPC that we're in right now.
Great stuff, Klaus. And I read somewhere that the data center industry consumes as much power as the airline industry. So what type of regulations are being placed globally to support reducing energy consumption?
Yeah, so I will talk about the European part, and maybe Saman, you can add some for US. So in Europe, this is a very, very important point where you are forced to reduce your energy consumption of those. So It different. It is even different from country to country. So some countries they ask you to achieve a certain level of PUE within your data center to not waste any energy. Other countries they force you, which is a good thing. So don't get me wrong. They force you to reuse the heat of the data center, and this is also easier to do on with different cooling solutions. So the regulations is totally different. And on top of this, it's also on as I said, on a company level, it is very different. So you have rules by the government in terms of water usage effectiveness, power usage effectiveness that you have to do. It differs from country to country, at least in Europe. You're also restricted in some countries by what cooling liquid you're using, meaning is it water-based cooling, is it a DIX, so a cooling gas or whatever. So even there are limitations, and they're not allowed to use like gas in the future and stuff like this. So a lot of complexity given there. Key and bottom line of all of those is the lower the power consumption needed for cooling, the better it is, obviously.
Thanks, Les. And from a U.S. perspective, I can see the basically the range of different regulations. I guess I'll call it regulations that we've adopted. At a city level or a region level, there's a little bit of a constraint on that we're seeing now with the advent of electric cars, placing energy consumption on the grid very high. We've seen different states adopt different internal regulations on how power is consumed in general. But we're really seeing it from the energy utility companies becoming more prevalent, adopting a method of providing credits to people who adopt responsible energy practices. I've seen that in Chicago, Virginia, California, definitely being the hotspot of regulation in terms of energy consumption. So we're really seeing a lot of cities and states kind of provide this type of regulation where the federal government has not yet stepped in, or not at the country level has stepped in to provide that type of regulation. I do suspect that we are on the track of having some of those. Like you said, Brandon, the data center industry is consuming all this power, and we're really we really got to do our part to reduce energy consumption wherever possible.
Right.
Absolutely. So I will move one slide on. So we talked a lot about different cooling solutions and densities and stuff like this. I just wanna display it or make it use a little bit of color just to give it a little bit of details and to make it a little bit easier. So when we just look at at one example, which is like very, very often and very common in use, like a crack unit. So you have your crack or CRAW unit that provides the cold air, and you hopefully use a kind of a containment, so to optimize this, which saves you a lot of headache. So with the containment, in easy words, to keep the air where you want to keep it, to not mix the cold and the hot air, which is something that you totally want to avoid. So you can use both. You can use hot air or cold air containment. It doesn't really matter what you prefer to use. Key is to not mix it. On a day one installation, where the theoretical load of every cabinet is even or is in between 3 to 10 kilowatt per cabinet or whatever, it is very easy to do, straightforward. You can do basically whatever is needed. So this is what we had when we started this whole thing and when we talked about sensors. So very, very easy. If the density in the cabinet increases, then this is where you need to think of what to do with it and where to place those. For example, when we look at the red highlighted cabinets, so those are displaying the cabinets with the highest load in this scenario. So The yellow ones are like mid power consuming cabinets. So this is something that you need to be aware of when we talk about placement. So meaning if you have like a third cabinet that needs a higher demand, obviously you have to check if your cooling system is able to provide the cooling power. And secondly, you have to look at your sensors that you hopefully are using to where to place this cabinet. In the worst scenario, you would place like two red or two high load cabinets within next to each other, which might cause a problem because they will consume a lot of the air distributed into the air containment, and there will be not much left for the others, or one cabinet just gets rid of consumes that much of the cold air that there is not enough for the cabinet next to it, which is also a high loaded cabinet. So you might run into problems. So sensors is very important. And then the funny thing is, so you know that you might face a problem. So what to do with it? I mean, it's not as easy as like there is no switch that you can run and say, so I need 25% more power or 50% or whatever. And even if you have this switch, then your efficiency is like totally meaning if you have to run your cooling system on the cabinet with the highest load, you might have really an overkill on all the others. So efficiency is PUE is like, forget about it. This is off the charts. So the interesting thing is, if you know you might face problems or whatever, so what to do with it. And this is why it might be wise to look at other cooling solutions to be very efficient and to be very precise in cooling. So you are down to like, you should consider like a rack level cooling for this. And there are different methods to do so. So on a rack level cooling, you end up very quickly either in the choice of a rear heat exchanger, on-chip cooling, or immersion cooling. So the thing is, immersion cooling, I will give it a few words later on because that's very, very specific, this topic. Rear heat exchanger and on-chip cooling. So on-chip cooling is something that you can't decide at any stage just on your own or just because of the will of it, because you need specific systems, meaning the servers need to be able to deal with liquid cooling. So specific systems that you need, and then you need also the water in your cabinet, which is, by the way, a good way. This is the topic of this webinar. So this is something that is way more important than the actual cooling solutions that you do. You need to provide the way to cool your cabinets, meaning you should think about distributing or providing the pipework within your data center for the future needs. So we are back to this scenario. We have more cabinets that needs to be cooled wherever it is, then, for example, an on-chip cooling because you change the systems in 1 or 2 or 3 of your cabinets, or you have just the high load with normal servers, and then you can use the water distributed within your data center, and you can attach, for example, a rear heat exchanger. A rear heat exchanger is cooling whatever load you have based on your cabinet. This solution is an air-assisted liquid cooling, meaning the heat exchanger is based on liquid cooling. In best case, it is a water. In best case, it's water. So it doesn't matter what load that you have in your cabinet. The rear heat exchanger can deal with it within its limitations, obviously, depending on the water flow and the temperature. But to deal with hotspots, for example, it is a great way to do. And you can add this in any scenario that you have. So if you use fan wall, if you use a crack and a craw, or whatever it is, it doesn't really matter. Also, if you use cold air containment or hot air containment, the configuration, there is no change needed. You can add a reader to solve a hotspot in any scenario. The good thing about it is the reader heat exchanger takes out your high load cabinet out of the equation, and in the same time supports your cooling system that is already running, because the only hot air you have is the distance from the end of your servers to the front of the coil of the reader heat exchanger, and that's it. The air that leaves the cabinet on the backside outside of the reader heat exchanger is cool air again, which can be directly used, consumed from every system next to it or in the whole room. So this is the complexity of the topic. You can help yourself if you think the step further and have your infrastructure ready to deal with what will be there in the future. Meaning, plan ahead, plan the pipe work. You need the liquid in your cabinet one way or another. So this is something that there will be no way around if it is then on-chip cooling or it is like a reader heat exchanger. By the way, on-chip cooling, so on-chip cooling is a very, very good solution, but please don't forget, if you use on-chip cooling, you need a second source of cooling, because all of your systems and your servers, if they use on-chip cooling, everything within this server that is not a CPU or GPU is not equipped with on-chip cooling and needs to be air-cooled. So you need a second source of cooling for your systems as well. Also, the transition, I doubt that any customer will have the cut from Monday to Tuesday and say, so we have all our systems, we throw them in the bin, and tomorrow we have the big boom and we just go on-chip cooling. This will also not happen. So it is the transition. And as I said, if you use on-chip cooling, you need air cooling for those systems as well. Depending on the system you use, between 10 and 40% of those servers is not cooled with the on-chip cooling. So if we look, just use plain numbers. If we have a cabinet with 100 kilowatt load, which is, it sounds very high, but it is not that big of a challenge with those systems. So if we talk about a 100 kilowatt cabinet between 10 and 40, so 10 up to 40 kilowatts needs to be cooled by air in addition to on-chip cooling. So if we are down to 10 kilowatt, you might be lucky and you have your crack unit, you use containment, so airflow management to optimize this. You might be able to run this. If you're looking about more to 40 kilowatts, then you look more for a combination of an on-chip cooling and a reader heat exchanger, for example, to get rid of the heat. So those are very, very important things. And the best thing to be safe is plan ahead and plan with the infrastructure you have. There is no way around liquid cooling or air-assisted liquid cooling that you will have to deal in the future to get rid of the heat and the load that your cabinets might have.
Yeah, Klaus, really, really well said. I think to your point on planning for the future, I think it really all starts from the cabinet level. I mean, I talk to data center managers all the time. And if you think that the IT refreshes that occur every 3 to 5 years, that's not the same as what is done on the cabinet level, right? So on the cabinet level, you're putting this piece of equipment, it's almost going to die with your data center. I've seen data centers torn down with cabinets inside. So making sure that you're not only your cooling, but everything starts at the cabinet. Your cabinet level cooling is important. Your load is important, whether it's applicable into seismic environments or could be a future seismic environment. These are all things that you have to think about when you're planning, because you don't know what you're going to get tomorrow, and those things are going to be with you for a very long time.
Oh yeah, and thanks that you brought in the topic of cabinets, because it is absolutely true that you have to think about this as well, because think about the size of a cabinet. So think about the future, and for example, a 600 watt cabinet with the higher demand in power. impossible. It is impossible to fit in because you need the space for the PDUs. And if you think about, or if you potentially think about like on-chip cooling, you need to place the manifold somewhere to distribute the water within the cabinet. So you even have to think about the easy thing like the dimensions of your cabinet to be safe. What this is, so to plan the step ahead. Absolutely, yeah.
Right. Now with manifolds, being added to the back of the cabinet, especially, I see things going deeper already. And for these types of power loads, we're seeing up to 8 PDUs being installed in the cabinet, depending on the type of environment and power sources you have within the data center. So, definitely.
And before we leave the topic, as well as the slide, gentlemen, how do you decide on which cooling solution you want to deploy in a data center?
Yep. That's a very good question. And to be very, very open about this, if anyone on the market at this period of time tells you so, you have to do this because it will look like this in 1 year from now or in 2, he will totally lie into your face. Reality is, at the moment, no one can tell you exactly what the future of cooling will look like. What I can tell you is that you be on the best step towards the future, meaning what is the best things that you can do to be ready for the future. So we have crack and in-row. I will not talk about those because they're just from a load point of view and everything. This is just it will not be the one for the future. Fan wall used very often, yes, but on its own also very limited and also hard to be precise in cooling and to be efficient if you have like a huge variety in rack densities. So what is true and what is reality? So there will be no way around of liquid cooling and also not on a rack level. So back to the thing again, we are down to the infrastructure and distribute whatever is needed, like the pipework and everything, to solve your cabinets. And then secondly, it is also the way of being ready for the future is also something. So you want to have a very high range that can be cooled within one cabinet. So meaning from the new start point of like 10 kilowatts per cabinet and above, you want to have something that can cool very effective on a rack-based level, independent of the power of the load of the cabinet, and therefore is the rear heat exchanger is a very good way to do this, because the rear heat exchanger it doesn't matter if it is the cabinet is loaded with 10 kilowatts and 2 weeks after it is 20 kilowatts and then it's 35 or 40 or 50. There is no change needed in the system itself. So the rear heat exchanger can run this on a very, very efficient level, and also based on the cabinet itself. So there is no need to run anything on 100% if it's just one cabinet needed. So this is something that you can cool down very precise. And the second good thing about if you look towards this kind of a solution, by the same time you also have the water already in the cabinet. So even if you then think about the next step, which might be the transition from your systems to on-chip cooling systems, you already have the water in your cabinet. So even there you can start the transition. So in a nutshell, there is nobody that can say right now, in 2 years, in 3 years, next year, this is the cooling solution and this is what you need to do. This is absolutely not true. But to show a way where you can be safe for anything that is that might appear or that might cross your way, this is something that we can absolutely do. And this is, as said, so the pipework and everything that you need to do. And then the trend will go like a combination of reader heat exchanger and on-chip cooling. This is what it's most likely will be. On the other hand, and this is where I will jump, so this question fits in there perfectly. So on the other hand, we have also the immersion cooling. So I said I will give it 1 or 2 words later, because this is something that is totally different from other cooling methods that we see. So if I don't believe it, but if anyone in here hasn't crossed immersion cooling, so this is like, what would be a good way to visualize it? It's a bathtub where you reverse deep fry your server. So this is how you can maybe imagine it. So it is a bathtub where you dunk in all your servers, depending on the liquid you're using and if it's one phase or two phase. So it is oil, or it is like a synthetic liquid. It has a very huge potential, the immersion cooling. Depending on how you use it and what liquid you use, it might have a bad impact on the environment. It is also not very easy to handle, so you need the systems to handle those. So it's easy said, you can dunk into any system, but as soon as you ask, then how about the warranty and stuff like this? So then everybody falls short. So it has a huge potential, and also reusing the heat, for example, with immersion cooling is one of the easiest that you can have. What no one talks about, for example, in immersion is it has also some downsides. So meaning you need the staff trained on the immersion cooling, so it's not as easy as the other things. If you have to test the liquid, and depending on what liquid it is, you have to dispose it and renew it every 2 to 3 years. So if you're using the systems just for yourself, maybe easy. If you host systems and you have like 100 clients on those systems, good luck finding a date where all 100 clients of you agree to, like, okay, we have a shutdown of the server because you have to renew the liquid and stuff like this. So it has a great potential, but there are also some downsides on it. So it might be the big thing, but it will be limited to some customers. This is where immersion will most likely position itself. And the other things is like what I explained earlier. I just made this chart to make it to give it a bit more visibility. So I used the snowflakes. Where is the potential of those? Just to have to give it an idea what to use. And as said, the trend will most likely be a combination of on-chip cooling and a reader heat exchanger. This is what we see in the market. I hope that
Klaus,
this gives an idea on what cooling solution to use.
Yes, thanks, Klaus. And the audience has also been seeing immersion as a type of cooling that is up and coming. And they wanted to know, does that follow the same type of approach as the air and liquid cooling solutions that you discussed earlier?
Yeah, so that's what I said. So the approach, so it is a total different style of solution. So that's why I tried to make it to visualize it with you deep frying your servers. So this is what it is. It has a huge potential. It has also the biggest impact on your whole infrastructure, and therefore on all of it. And finally, immersion cooling is also something. So what we see right now, so some customers, and by some I mean you can count them on one hand, are using immersion cooling in the data centers, which is on static systems or whatever. Absolutely. On most customers, it is like the proof of concept phase, that those systems are, they just are at the proof of concept, but then no next step or whatever. Reality is also, this is something that you might think of. So is it really the solution that I need? Because immersion cooling is like something, so the cost, I mean, you at one point you have to consider the cost, and this is the most expensive solution on day one that you can have. So it has the potential to have the lowest PUE, but the initial costs are by far the highest for immersion cooling. And secondly, it is also something like, do you need it in terms of the load? So for one tank of immersion cooling, we talk about a capacity of up to 400 kilowatt in one of those tanks, or maybe more. As said, it has a potential, but there are so many new questions with this topic. So this is a total new chapter, but for majority of the customers, I don't, the market sees no wide adoption in the next coming years on immersion cooling. It has its potential, but it's not a solution for every DC, let's say like this.
It's an all or
Thanks.
nothing, I think is what it sounds like. You're either all in on immersion or you're not. So there's no in between.
Definitely. Thanks, Klaus. And thanks, Saman, as well. Saman, did you have any final comments before we close here today?
Yeah, I think I see a question in the chat regarding seismic. On the containment products that we offered, the building within a building structure has the ability to be a seismic rated solution. That way, if you're in one of those environments and this solution is holding up your infrastructure, it will be rated, as well as our cabinets for the same. The last comment that I had.
Okay, awesome. Thanks, Saman. And we would like to thank you both for your expertise today. And before we begin with today's Q&A instructions, please direct your attention to our webinar survey available on the bottom of the presentation window. Thank you all in advance for filling out the feedback form. Again, your participation in this survey allows us to better serve you. And now on to the question and answer portion of our event. As a reminder, to participate in the Q&A, just type your question into the text box located on the right of your presentation window, or click the Q&A icon at the bottom of your screen. We'll be sure to share all of the submitted questions during today's webinar with our speakers, who can reply to each and every question submitted today offline. And so that is all the time that we have for our broadcast today. Again, we would like to thank you, Saman and Klaus. Data Center Knowledge appreciates your time and expertise on today's topic. And we would also like to thank our sponsor, Legrand, as well as to everyone in the audience today. We appreciate your attention and participation. Within the next 24 hours, you will receive a personalized follow-up email with details and a link to today's presentation on demand. Please feel free to invite your colleagues and peers who may have not been able to listen to today's event. This webinar is copyright 2024 by Informa. The presentation materials are owned by or copyrighted by Data Center Knowledge and Legrand, and the individual speakers you heard today are solely responsible for their content and opinions. On behalf of our guests, Legrand, Saman, and Klaus, I'm Brandon Taylor. Thanks for your time and have a great day.
Thanks so much, everyone. Look forward to hearing from you.